Well, thank you for joining me on exercise 3D. I'm going to be looking at question 1a and 1b. Without solving these equations, determine the nature of their roots. So we've got this quadratic equation, and the roots are when it equals to 0. Now, what we're after is, are there two? Are there one? Is there none? Are there none? Is there one? Are they real? Are they repeated? Are they distinct? Real? Are they irrational? Okay. So let's find out if there's 2 or 1 or 0. So we're looking at the discriminant, which is b squared minus 4ac. Let's look at the value that this gives. Now, a is 1, b is 3, and c is 7. So a is 1, b is 3, the coefficient of x, c is negative 7, the constant. So let's do b squared, which is 3 squared, minus 4 times 1 times negative 7. So we've got 9 minus plus, because there's 2 negatives, 4 sevens, 28. Now we've got 37. There are 2 because it's positive. Therefore, 2. And because it's not a perfect square, therefore they're irrational. Therefore, they're not rational. So 2, and they're two distinct real roots, or we know that they're not rational because it's not a perfect square. Two different, irrational roots. So if you wanted exactly, you'd have to use the square root of 37 would be part of the solutions. Without solving, so I can't solve it. Okay, let's look at part B. X squared plus x plus 2 equals 0. So a is 1, b is 1, c is 2. Let's look at the value of the discriminant. The discriminant is b squared minus 4ac. b, 1 squared, minus 4 times a is 1, c is 2. So it's 1 minus 8. Well, okay, we get negative 7. Well, you cannot get the square root of negative 7. That would be part of it. And so what we could do is we could say there are complex roots. So you could say there's two distinct complex roots, but because we're not dealing with complex numbers, I'm simply going to say no real roots. They will be complex, but no, it won't cross. In the real number system, there are no values. It'll never equal 0, no matter what x value you substitute. I hope this has helped. Until next time, stay happy.